This video file is recorded in Sabancı University during the recitations for the CS201 Introduction to Computing course, as it was given in the fall 2016 semester.
Good morning for the last time for this semester. These are our last recitations for this course, but we are not over yet. We have to cover, of course, we are going to do some preparations for the finals, but we are going to cover new topics, relatively new topics for you, which are kind of important. So the first, namely those new topics will be matrices and static data, static variables. So what's a matrix? And I want you to be engaged with me right now. You remember the arrays, the vectors? I'm talking about built-in arrays or dynamic arrays. Why did we discover arrays? Since we had a problem like this, we have students in Sabancı University and they take their grades, okay? So instead of defining something like this, double CS201, where I keep the grade of CS201 in this variable, then what, math 203, then whatever. Instead of defining 40 variables, I could define a vector of type double which has 40 elements from 0 to 39, okay? But this is only for one student. Let's say this student is student A. However, in Sabancı we have like maybe 3,000, 5,000 students. Is this feasible to declare an array for each of the students or not? What do you think? So I'm declaring a new array. I know I keep the grades of the students here. Then another array for another student, another array or vector for another student, and so on. Is this okay? So what should we do? Can you come up with a solution? One of solutions. Of course, there are many ways of dealing with this stuff, but one of the ways is this one. So any idea about this stuff? What do you think? How about if I put something like this? Have you heard about matrices before? For sure, you've heard it in math, if I'm not mistaken. You have seen them maybe in high school. If I declare something like this, basically this is a vector of vectors. And these are the rows. These are the columns. 0, 1, and minus 1. How many rows do I have in this matrix? N. And I have m columns. So in all I have n multiplied by m elements here. So this is a matrix. This scheme is called a matrix. The interesting part about the matrix is that all of the data here have the same type, okay? And it's kind of a rectangle-shaped scheme. I mean, I cannot say I have m minus 1 elements in the first row, in the second row I have 5 elements, in the third row I have 2m rows, no, 2m columns. I have here 5 columns, in all of the rows I have the same number of In all of the rows, I have the same number of columns, and the type is always the same. I cannot say I have here integer, here double, I have a string here, a character here, and so on. There is a good presentation, a few slides basically about the matrices. Let me show it to you. So you remember how I used to declare a vector. Let's say this was a vector. Here I put the type. For instance, it was double. I give the name. Let's say this is grades. This is the name of the vector. And I give the number of elements. In our case, it's 40. Now let's see how. So this was about declaring a vector variable, a dynamic vector. Let's see how I do this stuff for matrices, which are vectors of vectors. Basically, this is one vector. This is a vector. And each element of this vector is another vector, okay? It's called a vector of vectors. So let me introduce better to matrices. This is the way how I define a new vector variable. The syntax, how I do it. So I have a vector of vectors. That's why this is, I define a vector, and inside those brackets I should put the type. But the type of a vector is another vector, okay? And then I should define, and I put here the name. In this case I call this mat. I put the rows, and I put here the columns of the rows are this 1, 2, 3, okay? So here I put 3, and since 0 is a vector, 1 is a vector, 2 is a vector, 0th row, first row, second row, all of them are vectors, I put the size of each vector, or all of the vectors inside here. So basically with this is a general syntax of declaring a matrix, and concretely this is the syntax how I define, how I declare a type matrix. Okay, you remember how could I access an element in a vector? For instance, if I wanted to access the second element, meaning the one with index 1, I could do something like this. Grades. Since this is the name of the vector, grades. And in parentheses, I put 1. Then I access this guy here. Let's say its value is 3.3. Now, in matrices, I access a certain element in this form. I give the row first and the column. For instance, if I give 2, 3, and remember I always start from 0, both for the rows and for the columns. If I give 2, this is the second row, this is the vector of the second row, and if I want a concrete element in that row, then I give the second parameter, which is 3. And its value is 100. So I can access it with the number of the row and the corresponding column of that particular cell. By accessing, I mean I can read it, I can write it, I can change it, and so on. I can print it, I can do everything with that. This should be all for matrices. Now remember for the vector class, we had some parameters, some properties. One of the properties was pushback. With pushback, you remember, we could push elements. Okay, the same applies for matrices. When I call a matrix, I can push columns here. 1 column, 3. If I call a matrix for a certain column, let's say matrix 0, then I should push an element here. But the problem here is that we should be sure that the number of columns is always the same. Okay, that's why usually we push rows in the end, since the column remains always the same. We should be careful about that. Don't use pushback for matrices. So this is class matrix, or better, class vector of vectors. And here we have here the type. We can use here the size also. So in this case, if I've defined a matrix which is called mat, if this is mat, with mat point size, what do you think? What do I return here? What's the value of this guy? So this is the name of the matrix, mat point size. What do I return here? Nice way of reasoning, but actually I don't return n multiplied by n. With this guy, I only, because you remember, I mean, let's see the definition of a matrix, or how we declare a variable of type matrix. We say it's a vector of vector. Now for the size, for the vector, if I call the size function, what do I return? The number of elements. Okay, so here size is 40. If I say grades point size, I return the value, its value is 40. And here, I say that the matrix is basically a vector of vectors. So, what I'm returning with mat point size? What do you think? So, this is one vector, and each element of that vectors are vectors, basically, okay? Or we can call it, this is all a vector, better, this is all a vector, and this is the 0th element of the vector, which is another vector. This is the first element of the vector, which is another vector. So with mat point size, what do I return? What do you think? Yeah, your friend just gave that option, but it's not like. So this is a vector of vectors. The first element is this one. The second element of the vector is this one, another vector. Third element is this one. So what do I return? Number of rows. Exactly. So mat size returns number of rows. In our case, it's n, since we start from 0. Okay, you now might say, how do I return the number of columns? Can you give me an idea about that? I mean, did you see it in the presentations, or you came up with the solution? So you saw it in class. Yes. So mat size gives this size of the rows. If I say mat 0, I'm accessing the first element, meaning the first row, all of it. If I say mat 1, I'm accessing the second row, and so on. So when I access the first row, if I want to see the number of elements in that row, if I put size, what I'm returning, size, it's a function, number function, I'm returning the number of columns. The same applies if I call size for the second row, for the third row, since the number of columns is the same for all of them, okay? Usually we use the first index, 0, but you can use an index. So this is all about the matrices. Now, what are the operations that we do with matrices? We can print, we can read, we can find sum, and so on. Usually, or we can iterate the matrix. Iterate meaning we go through each element of the matrix one by one. Usually, this is how we iterate the matrix. We define a variable called I, and this I starts from 0 and goes up until n minus 1. Then we define another variable called j, or it can be any other. Don't stick with the name, it can be any name. And it iterates the column. So if I want to print a matrix, for instance, I start with I being 0, and I iterate j, this j here, this is I start with I0, and I iterate j from 0 to the end, n minus 1, okay? Then I increment 1, I to be 1, and I start with j from 0 till the end. I increment I to be 2, and I start with j from 0 till the end, okay? This can be done in what fashion? How can we do it? Usually it's done with 2 for loops. I have one for A, it goes from 1 to n, and another for j. This is not the syntax of C++, but just I'm telling you what I'm doing. Not from 1, from 0 to n minus 1. And j goes from 0 to n minus 1. Okay? So for each I, j goes from 0 to n minus 1. Okay? I is 0, j goes from 0 to n minus 1. I is 1, j goes to the end. In this manner, we iterate the matrix. We go through the matrix. Now let's see an example about matrices. I'm not sure whether you have it in your... This is, by the way, I'm not sure whether you have it in your folders. If not, you can ask for me to send them to you. And by the way, this is the first lab from CS204 also. If you take the CS204 course, this will be the first recitations. So let's see how it works. I'm just copy-pasting the file. And let's insert it. Let's add it. Okay, so this is our code. And I forgot to tell you that usually when we deal with matrices, we send them, when we deal with them with functions, when we want to send them as a parameter to a certain function, usually we do it with a reference. Okay, we send the exact data, not a copy of it. And if we want to be sure that we don't want to change it, we put this expression here, const, meaning it's constant and the compiler won't let us to change its value, any value of the matrix. So, how I iterate a matrix, you remember, I want to print a matrix, and I send the matrix as a parameter, as a reference. It's of type integer. Okay, so it's a vector of vectors. All of them are of integer type, and I send it as a reference, and the name of the matrix is called met in this function. Function is called print. It doesn't return anything. It prints the matrix. Let me first run the program. I think it will be better if I do that. Just let me ignore some stuff here. Okay, we don't need this part here. I'm going to comment it out. You don't need it. So this is the code we will be dealing with. You don't need this stuff here. It will be for CS204, advanced programming. Okay, let me run the program and see what's the output, and then let's go through the functions one by one. So, I'm prompting the user, I'm asking from the user to give the size of the matrix, namely the number of rows and the columns. Shortly put, we call those dimensions of the matrix. Let's say I'm giving 5 for the rows and 5 for the columns. And this is our matrix. I randomly put some data on the matrix, and I find the sum of column 0. It's this column. 1 plus 2 plus 3 plus 4 plus 5, it's 15. The sum of column 1 is 30. Up until the column 4 is 75, and the sum of diagonal is 55. The diagonal is this guy here. This element plus this one, plus this one, plus this one, plus this one. Okay? The matrix, I forgot to tell you also about this stuff, that the matrix is called a diagonal matrix if the number of rows and the columns are the same. Okay? And in that case, if we are dealing with a diagonal matrix, let's say like this one, we have 0, 1, 2, 3, 4 columns in total. 0, 1, 2, 3. So those elements here, if the matrix is a square matrix, meaning the number of rows and the columns are the same, it's a square matrix, this is called the main diagonal. And how can I access, what's interesting about this main diagonal? How can I access the certain data or all of the data in this main diagonal? I'm talking about their indexes. What's common about them? So, this is the main diagonal, okay? And how can I access this guy, this guy, this guy, this guy? What's interesting about that?
Row number and column number.
It's the same. Okay, so if the name of the matrix is, let's say, mat, then I can do something like this. Mat I access all of the data, okay? 0, 0, 1, 1, 2, 2, 3, 3. And I can iterate them with one for loop. So this is the main diagonal. We will see this is the reverse diagonal. And we will see how we can access the data of this diagonal later on. So let me first finish with this example. So we saw the output. Again, let me write it. And now let's go through the code line by line. We'll start with the print function. So it takes a matrix, a vector of vectors of integer type, and it prints it, okay? So you remember how we did this. We start for each row, meaning we start from 0 up until mat point size. The name of the matrix is mat. So mat point size gives the number of rows. I start from the first row with index 0, and I go up until the last row. And for each row, I iterate through each element of that row, meaning I pass here through the columns. So I start from k equals to 0 to k. Remember this guy, mat 0, point size. Mat 0 is the first row, and point size gives the numbers of columns, meaning the number of elements in that particular row, which is the number of columns, since all the rows have the same number of elements. So for each row, iterate through each element, each column, and print it. Set W is set width. It's just to print in more beautiful way the matrix. And I print the matrix with index J for the row and index K for the column. So basically, this is how I print it with this function. Set width. Okay? Yeah, but you will not have space. It gives only 4 spaces for the matrix to print it. Okay, you see, 1 has 4 spaces. 1, 2, 3, and 1 is put in, the one here. Of course, you can put the negative number. The minus sign takes 1 place. Okay, so I basically allocate 4 spaces for that number. Okay, and you start from the most right one. For number 2, the first row is number 2. It has also 4 spaces, and 2 is there, and so on. Okay, so it's set width. I think we've not used that in the CS201. This is the first time we use it. Yes? Yeah, it might be the case. Usually you use tab when you print elements, so you can use something like this. Not set width, but you use a tab. Something like this. So let me run it. Or empty spaces or whatever. Maybe set width is a better option. Okay, so we saw how we printed the matrix. Now we want to find the sum of the elements in the main diagonal of the matrix. Meaning, in this case, it's 1, 4, 9, 16, and 25. But remember, the matrix has a main diagonal if it's a square matrix, meaning the number of rows and columns is the same. So we assume here that when we take this vector, this matrix as a parameter, it's already a square matrix, and we find the sum of diagonals. So we start from 0, and we iterate from 0 to math 0 point size. Why? We can iterate, we iterate through the maximum number of columns, but we can iterate through a maximum number of rows. The number of rows and columns is the same. It won't make any difference. And you see, the indexes of the main diagonal are the same. KK, okay? So we add them up and we print the sum. Now we should find the sum of the columns, meaning 1 plus 2 plus 3 plus 4 plus 5, and the sum of column 0 is 15. Then for the column 1, it's 30, and so on. How do we do that? Again, we start from 0, but pay attention. Now we want to iterate for each column. That's why we start from the 0th column up until the maximum column, okay? That's why we use here math 0 point size. J, now we iterate the column. J is fixed to 0, and for each column we iterate the row. Then we increment the number of columns, we iterate the rows. We increment the number of column, we iterate and find the sum of that row. So for each column, we want to find the sum of that column. So we start from 0, and when we want to iterate the rows, of course, we start from the 0th row, we go up until the end, and we find it. You see K, since the row is usually, not usually, it's always like this. I think in all programming languages, the first index gives the row number, and the second index gives the column number. Basically, this is what I'm doing here. If this is our matrix, I put J to be here, then I iterate K, and I find the sum of these guys. This element is M math K, yes, math K, J. So in this case, we're not dealing with I. Here we have K for rows, and J for columns. J is fixed to 0, I find the sums. It's incremented to 1, then we find the sums, and so on. In the end, we print the sum of each column. As you can see it here, sum of column 0 is blah, 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 of 2, 3, 4. We do it with this line here. You see it's inside the for loop for a certain column. Now let's go to the main function, where we are going to use those functions that we already saw. So here we define integer variables j and k. We're going to use them as temporary variables. We define the rows and columns, which will be our input. So we ask from the user to give the number of rows and columns of the matrix. And finally, when we get the data, we define a new matrix, which is a vector, which is called met. It has rows, number of rows, and cols, number of columns. Now, this is a for loop just to fill up the data with kind of random, to fill up the matrix with random data. So we start from 0 for each row, for each column. So j are for the rows, the k index is for the columns, and we fill it up with kind of random data, which is j plus I plus multiplied by k plus 1. J plus 1 multiplied by k plus 1. And just to fill up the matrix. We fill it up, then we call the print function we already saw. We call the sum column function that we already saw to print the sums of the columns. And afterwards, we ask whether the number of rows on the columns that we entered are the same. If they are the same, that means that we are dealing with a square matrix. And since we're dealing with a square matrix, it makes sense only for square matrices when the number of rows and columns are the same to find the sum diagonal, meaning we are calling this function here. So again, this is our output. Let's go line by line. We are prompting for the rows and columns. We give 5 and 5. So rows is 5, columns is 5. Then we fill up the matrix with those two for loops. We print the matrix that we just saw. So we call this function here print. And this is how we print it with setWidth. Afterwards, we print two new lines. We have two new lines here. Then we find the sum of each column of the matrix with this function, sum column. And we print sum of column blah blah is this much. We print for all of them. And if the matrix is a square matrix, we print a new line and we find the sum of diagonals. If you see 1 plus 4 plus 9 plus 16 plus 25 is 55. Okay, now you have like 2 minutes to do the following job, and it will become towards your activity. We saw that how we can print the sum of the main diagonal, of the elements of the main diagonal. This is called the reverse diagonal. How can we find the sum of those elements here? This one, then this one, then this one, then this one. Do you have any idea about that? So what was interesting about the main diagonal, that the indexes for the row and the column are the same. 0, 0, 1, 1, 2, 2, 3, 3. What we can say about the indexes for the main diagonal, for the reverse diagonal? This is 0, this is 3. This guy is 1, 2. This is 2, 1. This is 3, 0. So it's not the same. They're very much different. So, what are we going to do? Any idea? Yeah?
Then decrement the columns.
Exactly. This is a nice remark. So, when we go here, we start from the minimum number of rows and maximum number of columns. Then we increment the number of the rows, and as we increment the number of the row, we decrement the number of the column. Increment the number of the row, decrement the number of column. Increment the number of the row, decrement the number of the column. By 1, okay? Incremented, decremented by 1, incremented by 1 here, decremented by 1. So, this was a nice hint basically. This is, if this is I, let me write it like this is I, index I, and if this is index j for the column, if we use that index, what can we say about I and j? I plus j is how much? So for this element here, it's 0 plus 3. It's how much? 3. What about this one here? 1 plus 2 is 3. 2 plus 1, 3. 3 plus 0, 3. But 3 is the number of what? The dimension, it's about since we're dealing with a square matrix, is the number of rows, actually the number of columns. Okay, this can be 4 or 5. So how many columns do we have here? Or rows? 4. If the number of the column or of the rows or of the columns was n, this sum would have been how much?
N minus 1.
N minus 1. Exactly. So if the index I is I, that what can we say about index j? That it's equal to, I is equal to n minus j minus 1. So in programming, as we have seen many times here during the CS201 recitations, very often you should come up with this kind of formulas. Okay? So if the index of a certain row is I, then the corresponding index of the column for the reverse diagonal is n minus j minus I, where n is the number of rows or rows of number of columns. That is the dimension of the matrix, basically. It's n by n. Do we agree with this one? Okay. Since we agree, then let's write. You have 2 minutes to do that. Let's write a function that finds the sum of the elements of the, don't stop it, the sum of the elements of the reverse diagonal. Okay? Do it. Or maybe you want to do it during the break or not. Can you do it now? I mean, I told you everything. If you can check how we did it for the main diagonal. Now for the reverse diagonal, for the main diagonal indexes were the same. So it was I here, I here, I here. For the reverse diagonal, we have this stuff here. So this is for the reverse. For the main, we had I is equal to j. This is for the main diagonal. This is for the reverse one. Did someone write that piece of code or not? Are you trying or not? If you have questions, you can raise your hand and ask me. But first, download the codes. You need help? Okay, I think that you'll need more than 5 minutes to do that, as far as I can see, so you can do it during the break, and we'll be back after 5 or 10 minutes.